soon. Yeah, I got quite a few emails after midnight yesterday, which is kind of annoying. I told everybody to make sure that you try to sign up to Gradescope well in advance and try to submit your assignment well in advance. And a bunch of you didn't do that. Some of the common mistakes people were making, if you still haven't fixed it yet, is to make sure that you're on gradescope.ca, not gradescope.com. Anybody that got an error with the class code, they're probably on the .com domain and not .ca. If you email me your assignment, I'm not going to grade emailed copies of assignments. It has to be on Gradescope, so get that sorted. If you're not able to get it set up, I'm not going to help you during class right now, but you can send me an email after class, and if you still can't get it working, then I can help then. Okay, moving on to polynomial functions, rational functions, and absolute value functions. We're also going to get to inequalities today as well. You'll notice in the course syllabus, I have some other stuff in here as well about graphing polynomial and rational and absolute, not absolute, sorry, just polynomial and rational functions. I'm actually just not going to cover that at all in this course. I think there's enough content in this course without that. And the techniques that I have to use for those graphing sections, they avoid limits on purpose. And you're just going to have to relearn it with limits anyway. So, yeah, if you look at what's in the course syllabus for June 27th, which is today, the graphing sections won't be in the course at all. I'm not going to cover them. They're still in the textbook, so you can read through it if you want. But I won't be covering it with you, and I won't be examining you on it. And you have your midterm at the end of the week. If you spent a good amount of time on your assignment, solving all those questions and doing your work independently, you should be well positioned for the midterm. The questions are quite similar, if a little easier even, I think. Like some of the assignment questions are a bit tricky, like the one where you have to complete the square underneath the square root and then isolate the x. So if you've put in a good amount of work with quizzes and assignments so far, you should be well placed. Just keep revising and studying and practicing questions and you should be fine. I'll post solutions to the assignment sometime in the next day or two. I'm just going to, there's penalties for late submissions for assignments, but yeah, I also want people to be able to look at solutions in advance of their midterm. So if you're very slow about getting your assignment in, there's going to be a hard deadline coming soon so that I can post solutions for everybody else to look at. I'm not going to post solutions and still accept assignments handed in because you can obviously just copy my solutions. So yeah, I'll post solutions soon so that you can see where you went wrong. I don't know when I'll have them graded. I'll start probably tomorrow to allow for the few late people to get their things submitted before I start. And I probably won't have your grades finished by Friday, but I'll post solutions so that you can read the correct way to do it and compare what you did with my solution, and you can see if you've done it correctly that way or not. Okay, so moving on to polynomials. Actually, before I go on, any questions about the assignment or the midterm right now? No, the midterm won't be multiple choice. It's going to be you write your answers and I can grade all your work and see your work. Yeah, if it was multiple choice, it'd be easier for me, obviously, because then I wouldn't have to grade it, but I need to see your work as well. So midterm and final are going to be long written solutions. Just like your assignment, really. You write out your solutions, except this time you have a time limit for it. Evan, is the assignment graded only on the right answer, or is the process graded as well? The process will be graded as well. A final right answer will probably get 0 marks if I don't see evidence of work, because I know that a lot of these questions I ask can be searched online, and there's online calculators that do a lot of powerful stuff now. So like if I ask, for example, what is the inverse, and I see no work to find the inverse yourself, it probably gets 0, unless there's something that I'm not considering. So yeah, it's the process as well. Midterm is Friday at 5, same as the quizzes. You can always, if you're not sure about when something is or when something is due, check the course syllabus. I had a few questions asking when is something happening. So check the course syllabus to find out dates and things like that. That's all in there. If the process is correct, but you get the wrong answer, I see your correction, do you still get some points? Yes, yeah. If you have the correct process, and then at some point you bring a plus sign across an equal sign and forget to change it to negative, I'll probably just take a point off for that mistake. So if I can see that you're still doing the correct things, you'll get some marks. How many questions? I can't remember. Either 6 or 7. How long do we get to finish the midterm? It's 1 hour. So this time I'm a little less flexible about when you can log on and start it. I want everybody on the exact same time frame here. So from 5 o'clock, the midterm becomes available. 6 o'clock you stop, and then you have 15 minutes to get it onto Gradescope. Same way as you would the assignment. You can take pictures on your phone, upload through your phone's browser. Whatever your way was to do it for your assignment, you do that again. So you get 15 minutes after the 6 p.m. deadline to get it onto Gradescope. What's the time frame? 1 hour. 1 hour for this. So a lot of these questions you can find in the course syllabus as well. So if you come away from this going, what did he say again, or what were all those questions he answered in class? Most of the answers are in the course syllabus. You can look that up on Canvas, and you can reread again. And if there's something in there that I haven't mentioned yet, just send me an email and I can clear it up then. Okay, so okay, polynomials. So we've already seen some polynomials in this course, right? For example, 2x plus 3 is a polynomial. X squared plus 5x plus 6 is a polynomial. We've seen some cubic ones as well. X cubed plus 7x squared minus 9x plus 3. Those are polynomials. In general, this is just some terminology you might see. Polynomial is a function, let's call it p of x, of the form a subscript n x to the n, a n minus 1 x to the n minus 1, a to the n minus 2 x to the n minus 2, and so on, plus a2x squared plus a1x plus a0. Now each of the ai, those are real numbers, and we also require that an is not equal to 0, the very first one. Then it's a polynomial of degree n. So that's that's a general definition of a polynomial, and you might see language like that in textbooks as you're in university. So I wanted to touch on something a little bit general like that. So for example, looking at the polynomial up here, let's say it's x squared plus 5x plus 6. This is like the polynomial, let me write it in the language above, like a2x squared plus a1x plus a0, where a2 is equal to 1, a1 is equal to 5, and a0 is equal to 6. So this is just about creating a general language for what is a polynomial, so that when I say a polynomial, you know that I mean, oh, it could be any kind of length, it could have any highest power like that. It's not just limited to linear, quadratic, cubic, and so on. We now have an idea for generally what is a polynomial. It's something of this kind of form. The cubic one that you see above here, that one here would be the same kind of thing, except it has an a3 x to the 3. So it's really just about the language here. So solving polynomials. We did this a little bit when we looked at quadratics at the end of the last class. Was that the last class? We had the quadratic formula. So you could solve it with that formula, minus b plus minus the square root of b squared minus 4ac all over 2a. You could factor it, and you could set the factors equal to 0. These are ways that we have to solve quadratic polynomials. So now we're going to try to solve bigger polynomials as well. Now, some of these it's not possible to solve them. Not every polynomial even has solutions. Like we saw this before with the quadratic polynomials. If your discriminant is negative, then you actually don't have any solutions, no real solutions. We're not dealing with complex numbers in this course. So for anybody that's seen complex numbers before, you don't need to worry about it for this course. We're just talking about real numbers here. So solving polynomials is going to work in the same way, in that the first step that you try to do so the first thing to try is factoring. Again, these foundations that we touched on in the very first class, factoring, it becomes important again. So for example, let's say I want to solve, what was I going to talk about here? This one's from the textbook actually. 8x cubed minus 4x squared minus 50x plus 25 equal to 0. And I'm sure you know this, but when I use the language solve some equation like this, what I mean are find the values of x that make the equation true. For example, if I put 1 into here, what do I get? I get 8 minus 4 minus 50 plus 25, something that's not 0, so 1 doesn't work. It's not a solution and it doesn't solve the equation. Maybe 2 does, maybe 4 does, maybe negative 5 does. So I'm looking for those numbers that make the equation true. Okay, so when you're looking at this, often when you see a problem like this, if something looks familiar, you kind of know what to do, even if you're not sure where it's going. But looking at this here, I see that this can be factored by grouping in the groups that are right here. So for example, for the first group here, I'm looking for the common term between 8x cubed and 4x squared. So that's going to be 4x squared. When 4x squared is factored out of that first group, I'm left with 2x minus 1. Why isn't it working? Minus 1. And what's common between the 50x and the 25? 25 is what's common. And if you think about it for a sec, what I want to do is factor out the 25. Sorry, factor out the negative 25, not positive 25. Because factoring out negative 25 leaves me with a term that is the same as this one here. So factoring out negative 25 leaves me with 2x minus 1. So now moving on, the 2x minus 1 is here, and it's also here. So that can now be factored out as a common term, leaving me with 4x squared minus 25. That 4x squared minus 25 can be factored further, because that is 2x to be squared minus 5 to be squared. So I'm a little bit fast through this because I'm hoping that you're good at the factoring by now. And using the difference of squares formula, that's 2x plus 5 times 2x minus 5. And now, just like with the quadratic factoring, what we say is that in order for this term here to be equal to 0, so in order for the left side to be equal to 0, then either that must be 0, that must be 0, or that must be 0. Because the only way that things can multiply to make 0 is if one of those factors equals 0. So I can have 2x minus 1 equal to 0, I can have 2x plus 5 equal to 0, and I can have 2x minus 5 equal to 0. Now solving this one, I get x equals a half, x equals minus 5 over 2, and x equals 5 over 2. So those are solutions to the polynomial. And going back up here, the question was to solve this thing equal to 0 using the factoring techniques that we know. We were able to factor it fully, and then it's nice in a factored form because you can say in order for the product of these things to be equal to 0, one of them must be 0. I have to mute this. On vibrate maybe. I'm really trying not to miss this call. Could barely sleep last night with the heat without the aircon working. Oh, okay. So as I mentioned, the first thing you're going to try to do is to factor, and to see if you can put it into a factored form like this, and then say, well, if it's going to work, then the factors must be equal to 0. Or the options are, the first factor can be 0, because then, like if we look at this one here, if x equals a half, if you stick a half into this value in here, 2 times a half is 1, 1 minus 1 is 0. So what we have here is 0 multiplying by everything else, which is going to make the whole thing 0 no matter what those other terms are, and then the thing is equal to 0. Likewise for the second factor and the third factor. But one issue though, and you may have seen this as well over the last few weeks, is that sometimes things don't factor very nicely. You might want something in a factored format, but you're not able to. Like for example, even with those quadratic ones, you might have the minus b formula giving you some horrible answers that you would never have been able to factor to begin with. Sometimes there are no answers at all. So what do you do in those cases? Well, we're quite limited in what we can do. We can't always find solutions because there are not always solutions, but there's some things that we can try. That's just what we're going to be covering. Now, before we move on to more complicated polynomials, moving on to other methods, what I want to do is give you a reminder of polynomial long division. Before I start here, could we do our thing 1 to 5? How comfortable do you feel with polynomial long division? 1 is not at all, 5 is totally comfortable, 2, 3, and 4 are somewhere in between. Very split. Yeah. Okay, a few ones. I definitely won't rush through it then. And some kind of mediums, 2, 3s, and 4s that we're going to push into 5s after the next 20 minutes, I hope. It'll take practice, but I'm going to run through it again. So a reminder on the polynomial long division. Let's say, honestly, the easiest way to do it is with examples, is to just show the technique, and you'll then be able to do practice yourself. let's say I want to divide this big polynomial by the smaller polynomial and see what I get. Now, in the textbook as well, you'll also find synthetic division. I'm not going to cover that in class because synthetic division doesn't work in every situation. But polynomial long division should work in every situation. Synthetic division is very handy and very fast for easier questions. But for some of the harder questions, it doesn't work. So I'm only going to cover polynomial long division. And you can read through my explanation of synthetic division in your own time if you want. It's a handy one, but it's a little weaker than polynomial long division. That's why I don't cover it. But that said, if you use it in an assignment or in a midterm or test of some kind, if you do it correctly, you'll get full marks. Okay, so here's how it's going to work. The way you set it up like I'm starting it here. 2x cubed plus 3x squared minus 8x minus 5. So I'm arriving pretty late. I'll admit them this time, I guess. Okay, so it starts by dividing the front term here into this front term and writing your answer above that front term. So the first step I'm doing here is 2x cubed divided by the x. And that's going to be 2x squared. That is what I write up here. Okay. Next, what I'm doing is I'm taking that 2x squared on top. So let me just remove these because it's going to get messy if I don't remove as I go. This 2x squared here is going to be multiplied by this below. When I multiply it, 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. That gets written below here, directly below. So you line up the powers with the same size power directly above it. So I write the cube power, which is here, directly below the cube power, which is here. The squared power here, directly below the squared power here. So this technique might remind you a little bit of regular long division with numbers, if you can remember that at all. Honestly, I can barely remember that because it's been so long since I've done it. But it might be ringing a bell for you for regular long division of numbers. Okay. Oh, I've missed my cube here. Next, what we do is we subtract what we just wrote down from the line above. So to subtract, you're going to change both of the signs here. So change both signs and subtract from the line above. So when we do that, 2x cubed and 2x cubed cancel. 3x squared minus 4x squared is minus x squared. And then finally, we bring down this negative 8x, the one that didn't get touched in the previous step, and we start again. So 4 is going to be to bring down the minus 8x and do it again. Except this time, you're not going to divide the x into the 2x cubed. This time, you're dividing the x into the negative x squared here. Dividing the x into the negative x squared, you get negative x. So maybe I'll keep writing the steps on the right here. Negative x squared divided by x is negative x. And then, just like before, let me take away some of these markings. This negative x, okay, I didn't want to use black here. this negative x here is going to multiply by the x plus 2. And that answer gets written below the one that we just have right there. So that one is going to be negative x times x is negative x squared. Negative x times 2 is negative 2x. So what we did there was we multiplied this thing that we just solved, the negative x, by x plus 2, the divisor, to get negative x squared minus 2x. Okay. At any point, if you have a question, just pop it in the chat. And I'll see it. I'll see it as I'm constantly glancing up. And the same thing happens again. We're going to subtract from the line above. So to subtract, we change both of the signs and add them. So minus x squared plus x squared cancels. Minus 8x plus 2x is minus 6x. And we have one final round. So I'm stopping right in the steps because it's beginning to, you should be beginning to see the repetition happening now. So this time we're dividing the x here into the negative 6x to get negative 6. And then we multiply that negative 6x by the x plus 2 to get negative 6x minus 12. Again, we subtract, changing both the signs. Those cancel, and minus 5 plus 12 is 7. And now we're finished. You know that you can stop when you can't divide the x into the 7 anymore. Once you get a number up here, screen pen keeps failing to write. Once you get a number up here, you can't go any further. Okay. So some terminology. This here is the remainder. This is the divisor, the x plus 2. Okay, that looks like I'm just pointing at the x, but what I really mean is x plus 2. What do you do with that 7? Oh, we'll get there. So I haven't written the final answer yet. The 7 is going to be just a part of the final answer. This here is this thing on top is the quotient. This terminology, you don't really use it that often. And the thing that you originally divided into is the dividend. So I'll scroll back to this soon, but I need to scroll down to write some more. So what you do when you do long division here is you have a dividend divided by a divisor. That's going to be equal to a quotient plus the remainder over the divisor. So what we've just found out from this, so here's our final answer to this. If you were to stop, let's say your question was just do this long division. If you were to stop here, that you wouldn't be at full marks yet because you haven't really finished it. Like, what's the answer to the question? What is 2x cubed plus 3x squared minus 8x minus 5 divided by x plus 2? This is a bunch of work in the middle, but there's no communication of like, what's the answer? Here's what the answer is. So you're going to say that 2x cubed plus 3x squared minus 8x minus 5 divided by x plus 2. Okay, the quotient is the bit on top, 2x squared minus x minus 6. Plus the remainder, which was 7, divided by the divisor, which was x plus 2. Okay, that would be the final answer. Whoops. Now that right there is just long division without any context. I'm reminding you of this for a reason, because it's going to help us in solving certain polynomials. So it seems a bit random to divide it and then get an even more awkward looking expression. But it will be helpful when we're solving polynomial equations, and particularly helpful when that remainder is going to be 0. And that will happen, we'll talk about that soon. But very often that remainder is going to turn out to be 0 because of some theorems that I'm going to show you soon, okay? But just back to the mechanics of the polynomial long division. Are there any questions about any of the steps up here? So maybe what I'm going to do is run through it with some highlighter here. We started with x into 2x cubed and got 2x squared. The 2x squared got multiplied by the x plus 2 to give us this line here, 2x cubed plus 4x squared. When you subtract it, you can subtract that from the line above. The way that I like to do it is just change both signs and add. I think it's the way that leads to less mistakes. The 2x cubes cancel, and you're left with negative x squared down below. And then in the next kind of round of it, this x squared here is divided into the negative x squared to give us negative x. It's not marking, negative x. And then the negative x gets multiplied by the x plus 2 to give us this line here. And we keep going through the process until we get down to a remainder. Okay. Keep going. Any questions about it? About the process? Okay, can everyone give me a 1 to 5 in the chat this time? Hoping to see some higher numbers after the reminder. Very good, very good. Okay, very, very good. So make sure that you do practice this a bit. There's questions in the textbook as well. You're feeling good about it, but I know that it can be different watching me do it, and I'm persuading you that each step works, but then you have to remember it and do it independently as well. So you feel good about it, but do make sure that you practice it away from notes and away from me and everything, and make sure that it's definitely as solid as you think. But we're going to get a bit more practice as we do it anyway. So, okay, I'm going to stop sharing for a sec here and switch over to the book, because I want to take you through a couple of theorems that are actually going to put this to work, this polynomial long division, and help us solve polynomials with it. So on its own, it kind of feels like an arbitrary calculation, like divide this number by that number just because. But we're actually going to use it to solve equations. And if there was any part of this that that you weren't sure about, on page 67, you can read through the exact same question here. At least I hope I got the same answer. Yeah. And I have all the steps outlined here. Divide the x from the divisor into the 2x cubed and the dividend, and you place it above. Oh, so I placed it above the x squared term over here. It doesn't matter where you put that thing on top. Yeah, I think the way I learned it originally, I'd always placed it directly over the first term. And then I think I saw in a textbook over here that they placed it over the second term. It really doesn't matter, but I think when I was writing this, I said over the second term, but my habit is over the first term. It amounts to the same thing in the end. Another example here in the book for you to read, this is a little bit bigger. This one starts with an x, looks like I have a typo. This here should have been x squared plus 1. So I should take a note of that and fix it at some point. Typo in book, page, what are we on, page 68? Page 68, divisor, should be x squared plus 1. Okay. So this divisor right here, not letting me highlight it, but that should be x squared plus 1, because you'll notice in the calculation, I did it with x squared and not with x. I wrote down the question wrong on that one. And in the final answer, you'll notice divided by x squared here. So it looks like I missed my power of 2 when I wrote this question. But another one to check out. This one can be a little harder because it's not just x dividing in, it's x squared. And you're actually missing the x term. It's a polynomial that's dividing in that it doesn't have like, it's not like x squared plus x plus 1 or x squared plus 2x plus 1. It's just x squared plus 1. So you'll notice that I'm strategically leaving gaps, so that I don't accidentally add an x cubed and an x squared term by accident. That I'll do it correct. So you can check through this this method here for this one, and is everyone okay to go through this on their own, or do you want me to run through the calculation on the screen? Anybody have an opinion? Okay, I'll do that one on the screen as well. It's a little more complicated. Okay, so this was example. Oops, what's happening? Example 4.1.2 on page, it was page 68, wasn't it? Yeah. Sure, I'm in the right spot here. I think I am. Okay, so this one, we're dividing in x squared plus 1 into x to the 4 minus 3x cubed plus 4x squared minus x plus 2. Okay, it's going to start the same way. It looks more complicated, but it's going to start in the same way. We start off by dividing the x squared into the x to the 4 term, so the front term into the front term. And when we do that, we're going to get x squared. So over here, what I'm thinking of is x to the 4 divided by x squared, which is x squared. That x squared is going to multiply by this row here, and it's going to give me x squared times x squared is x to the 4, and x squared times 1 is x squared. Now what I'm going to do is write that directly underneath the x squared term above it, because that's the one that it's going to add with. So I'm leaving a gap there. Okay. I'm just going to remove these lines because it's going to get kind of clogged up if I leave them there. We subtract from the line above, so both of these signs are going to change. The x to the 4s will cancel. This is essentially negative 3x squared, sorry, negative 3x cubed plus 0 or minus 0, whatever it might be. It's just going to remain as negative 3x cubed. Why do I put under? Because it in itself is an x squared term. I like those powers to line up just for convenience. That's a habit, really. It's not something like you're totally and completely wrong if you wrote it closer. It's just because it's really just because I wonder, for example, if I was to write this under here, would I accidentally go 3 minus 1, minus 3 minus 1 is minus 4, and sort of miss that they're different powers? So it's just me making sure that I'm not going to make a mistake, that's all. So I like to put it over here. Okay. And then 4x squared minus x squared is 3x squared. And then we bring down this negative x. Yes, you can only subtract with the same powers. Like, it looks funny because it's in this kind of vertical sort of, it's going downwards, right? But if you saw x cubed plus 3x squared minus 7x squared plus 2x plus x plus 3x minus 7. You would say to yourself, okay, x cubed, these are the squared terms, so I have to add these together. I don't add a squared term with a cube term. These are all just x terms, so I'm going to add these together and get 6x, and the minus 7 is here. You would only add the powers with the same powers like that. The same thing is happening in this setting up here. It's just that it's kind of a vertical addition. It looks different, that's all. The minus 3x squared, so that's a little bit like, what do I do with that? Or this term here. It doesn't add with anything, so it stays the same. There's nothing there. It's like x cubed plus 0. Plus 0 times x cubed or something. Okay? So if that doesn't have an x cubed term to add with, treat it as 0. Oh, sorry, I changed that in when I was explaining about a mistake that I might make. I changed that to, yeah, it should be minus 3x cubed. So a second ago, you might remember I moved this term over here and demonstrated a mistake that I might make with doing that. Yeah, you can just drop it down. Okay, get rid of this stuff here. I'm glad you caught that actually, because I would have had a mistake moving on for the rest of this question. Okay, so going back in again, I'm going to divide in the x squared into the negative 3x cubed and get negative 3x. So minus 3x cubed divided by x squared minus 3x. Minus 3x multiplies by that front line just like before. And we get minus 3x cubed. Minus 3x multiplied by 1 is just minus 3x. Again, I want to line that up with the other x term, not with the x squared term, and subtract from the line above. So this is going to be a plus, this is going to be a plus. This will cancel. The 3x squared comes down. 3x minus x is 2x. And one more round to go. X squared into 3x squared will just give me 3. 3 times x squared is 3x squared. 3 times 1 is 3, so I'm going to write that over here. Subtracting from the line above. I'm going to be left with 2x minus 1. So my final answer, which was to the question x to the 4 minus 3x cubed plus 4x squared minus x plus 2 divided by x squared plus 1. That is equal to the thing I found on top, which was x squared minus 3x plus 3 plus remainder, which is 2x minus 1, divided by divisor, which was x squared plus 1. So that's my final answer this time. A little more complicated, but the method is the very same, just some possible mistakes to navigate, and a slightly different layout, that's all. Okay, so the answer to that one is in the book as well. I'll stop presenting here and restart again with the book. So I mentioned as well synthetic division. This might look familiar to you. It looks like a long method here in the book, but it's actually very, very quick. So it might be worth your while to read over that yourself. It's a nice little method, but it doesn't work in every case. For example, it would work in, I think, the first question we did, but not the second question. So it doesn't work if your divisor is like x squared or something like that. It only works if it's kind of a linear thing into a polynomial. Yeah. So I'm going to skip through synthetic division. I definitely would recommend that you read that yourself, though. You might find that you like the technique a lot for some of the easier questions. Because what I really want to get to we had to take a big sidebar to go to polynomial long division. What I really wanted to get to was these two theorems here and how you're actually going to use the long division to solve polynomials. So the remainder theorem and the factor theorem are the important ones here. The remainder theorem, let p of x be a polynomial. So just like what we saw earlier, it's for any polynomial, not just for x squareds or x cubes or cubics or whatever. If px is divided by a linear factor, which is in the form ax minus b, then the remainder will be p of b over a. So that's an interesting one. If I just asked you what is the remainder, if I divide this thing into that, then all you have to do is sub in b over a into the polynomial for x and see what you get left with. So that's an interesting one. And what we're actually going to be using though is the factor theorem, which is kind of like a special case of the remainder theorem. And if the polynomial px has a factor ax minus b, so if ax having a factor means that it divides in without a remainder. So if it has a factor ax minus b, then that happens if and only if b over a is a root of p of x, meaning that if you sub b over a into the polynomial, you get 0. That comes from the remainder theorem directly above it. Because subbing in b over a gets you the remainder, and if it's a factor, then the remainder must be 0. Now, that is useful because if you can stumble across a root, then you know that if you sub in b over a, those numbers from the root, you get 0, so that the remainder is 0, which means that if you divide in, you get a remainder of 0. You know if you know a root, you know a factor, and the quotient that you're left with on top after the long division, that's often easier to solve than the original thing. So what I'm thinking of mainly is cubic polynomials here. I'm looking at a cubic going, I wasn't able to use my factor by grouping, so I need some other way to solve it. None of the terms group nicely for me to factor, so what do? You might look at a few numbers and say, oh hey, look, it looks like if I put 1 in, it works. 1 is a root, therefore x minus 1 is a factor. So I can use long division, dividing x minus 1 into the big polynomial, and what I'll get is the quadratic out on top with the 0 remainder. Okay? So it's hard to talk about this all kind of in advance. If you have this question, then here's 10 steps to get to the answer. So I'm going to run through a few examples of it. How do I know when that happens? When what happens? How do you know a root? How do you figure out to be able to do this division? Yeah, unfortunately, there's not a nice way to just know the root. It's sometimes by trial and error. Now, in future courses, you might see some theorems that will help you find roots if they exist for polynomials. There's one called the rational root theorem, for example, that tells you if there is a rational number that's a root, it has to be of these forms if you take these numbers in the polynomial. There's another one called Rolle's theorem, which talks about the negatives and negative roots and positive roots. There's a few other theorems that we're not going to cover in this course, so we're kind of scratching the surface. For this course, it will just be if you can identify a root with some trial and error. So if I'm giving you a question that says, solve this, I will make it so that a root of it is going to be some small whole number, like 1, -1, 2, -2, 3, -3, something like that. You can find it by testing, and once you've found it, then you can use your long division. And in future courses that you take, you might get to experience solving polynomials with more theorems that help you find roots and not just kind of guesswork like we're going to be doing here. If it's something you're really interested in, though, in particular, the rational root theorem is one that helps. Now, you don't even always have roots, so it's tough. But the rational root theorem is something you might want to look up, but maybe not until after you're quite comfortable with this, because it kind of comes later. So yeah, this is a lot of what we do here. You're going to be like, why are we doing this? But you'll see in time. It can look like arbitrary stuff for now. Sorry, so to sum up for your question, it's basically guesswork for now. You're going to trial and error. Try 1, try -1, try 2, try -2, stuff like that. Okay, so okay, this one is in the book. I'm gonna take it to the screen because I hate just reading it. It's hard to keep it interesting. I really hope I don't miss a call. My phone will stop beeping. I'm gonna go off silent. Okay, so as an example, let's say this one is from the book, and you can read over this if there's something that you didn't get. Let's say we have to solve x cubed minus 2x squared minus 5x plus 6 equal to 0. So your first thought for this one should be along the lines of, okay, I see a polynomial here and I'm going to try and factor it. Because if I get it into a factored form, then I can set each of the factors equal to 0 and solve the roots that way. So I look at this for a second and I say, okay, in the order that the things are currently listed, I don't see it factoring nicely. The x cubed and the 2x squared, sure, I can take x squared out, but the 5 and the 6, I can do nothing over there. I might swap the minus 2x squared and the minus 5x and see does something work. It doesn't. I might try lots of things. Nothing looks like it's going to work right now. So I go, uh-oh, this is one that I can't get started. Okay, so just jotting that down. The first thought is to try and factor. When I do that, I think, uh-oh, won't work. So need to find a root with trial and error. Okay, so let's start with 0. Let's try, let's say x equal to 0. What happens if I sub in 0? So what I'm going to do is just call this p of x for handiness here. P of 0 is equal to 0 cubed minus 2 times 0 squared minus 5 times 0 plus 6, which is equal to 6. That did not work. What I'm trying to do is solve where this equation equals 0, not where the equation equals 6. So that one is not a root. 0 is not a root. Let's try, let's say -1 next. So I sub -1 in here, and what do I get? -1 cubed minus 2 times -1 squared minus 5 times -1 plus 6. Okay, a little bit more work to do here. The zeros don't just all work themselves out. -1 cubed is -1. -1 squared is 1, but then it's multiplied by -2. -5 by -1 is +5, plus 6. 6 and 5 is 11. 11 minus 3 is 8. That one did not work. So -1 is not a root. Let's try x equals 1. 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. What do we get? 1 cubed is 1. 1 squared is 1, so 2 times 1 is 1. Minus 5 plus 6. I think this one works. 1 plus 6 is 7. Minus 2 minus 5 is -7. That does add up to make 0, so I'm thinking that that works. So x equals 1 is a root. That means that x minus 1 is a factor. That's from the factor theorem. And I mean, this is something that you see all the time, right? When we solve quadratic equations, when you find the factor, you bring the thing across the equal sign to get a root. So if you have a root, you have a factor. And if you have a factor, you have a root. That's a factor. So what we can do to find the rest of the factors is to use long division. So now that we have a factor, use long division. So x minus 1 gets divided into, what was the original polynomial? X cubed minus 2x squared minus 5x plus 6. So I'm going to run through this a little bit faster because it's one of the basic ones and everybody felt pretty comfortable with long division after I did the basic one. So dividing in, you get x squared here, and multiplying x cubed minus x squared. I'm going to change the signs and add that way. So minus 2x squared, whoops, I should have written power 2 here. Minus 2x squared plus x squared is minus x squared. But if you have your answer from factoring in brackets, you flip the signs when you take it out of yours. Yeah, pretty much. So just going back up to here. I had this here was in a factored format. So think of it as like setting each of the factors equal to 0. In order to get the answer, you're going to move the number across and then divide by 2. Okay. Yeah, okay. Just wanted to double check I was answering your question. Okay. So continuing on, x into negative x squared is negative x. Multiplying the negative x, I get negative x squared plus x plus minus 5 minus 1 is minus 6. X into negative 6x is negative 6. Negative 6 plus 6. Changing my signs. And surprise, surprise, I got 0 as a remainder. That's something I was expecting because from our work earlier, we found out that 1 was a root and then that minus 1 is a factor. So if you divide a factor into a factor in, you should get 0 as a remainder because it's a factor. Like by the definition of a factor, it doesn't have a remainder when you divide it in. Like for example, 3 is a factor of 12 because 3 divides into 12 without any remainder. It's just 3 times 4, not with a remainder of 1 or whatever else. Same thing applies to polynomials like this. So writing my final answer this time, or I'm going to write it in a slightly different format here because it's more convenient, but x cubed minus 2x squared minus 5x plus 6, I think it was. Yeah. That is equal to the thing that I found for the first factor. The second factor is that quotient that you have up there. X squared minus x plus 6, or minus 6, minus 6. Okay. Now this comes from the same thing as the long division, because if you remember, in the long division way of writing it, you would have divided by x minus 1. It would be this over x minus 1 plus 0 over x minus 1 here. So that 0 remainder just goes away. And you can multiply across by the x minus 1 to get you what I currently have there. Okay. So we're almost there. Now, can we factor this term, x squared minus x minus 6? Numbers that multiply to make negative 6, that add to make -1. I think we can factor that one. You could also use the minus b formula if you wanted. -3 and 2. Thank you very much. So that means that if we want to solve where this is 0, which was the original question, right? We were trying to solve this polynomial equal to 0. Well, we already had this one, right? We had found this by trial and error. X minus 1 equals 0. X equals 1 is one of the solutions. These are the other two ones. X minus 3 is 0. So x is equal to 3. And x plus 2 equals 0. So x equals -2. So we found the answers. 1, 3, and -2 were the answers. Okay. How do we feel about that one? Any questions here? Everyone's feeling good? Okay, I'm going to do one more of these because that's actually a question as well. Has anybody seen this in high school, like a question where you would have to solve a polynomial like that and use long division in the process? I assume you've seen long division. I assume you've seen factoring. Has it been put all together like that for you yet? Any yeses or nos? You've seen this before? Never, okay. But you've seen the long division and the factoring and quadratic equation and things like that. So it's just kind of put together now, that's all. Okay, good to know. I'll do another one then. So solve x to the 4 minus x cubed minus x squared minus 2x equal to 0. Okay, so straight away, can anybody see a solution to this one? Yes, that's the first thing you want to do here. So x to the 4 minus x cubed minus x squared minus 2x equal to 0. Yeah, the first thing you always look for is to factor the common factor if you can. X cubed minus x squared minus x minus 2 equal to 0. And then to solve, you have two factors now that are multiplying to make 0. Why will this not write? X cubed minus x squared minus x minus 2 equal to 0. That's one. And yeah, this second one that we have here needs a bit more work, right? So we already have an answer. X equals 0 is one of the answers. And you'll notice that if you plug x equals 0 into the original equation, sure, you get 0 minus 0 minus 0 minus 0 equals 0. So 0 works. That's something you might just spot straight away. Okay, so I'm going to call this one q of x. So we want to do some trial and error to try and find a root of q of x. Okay, I'm going to try 0 just for completeness here, but clearly it doesn't work because I already have my solution of 0, and when I factored out the x squared, it left me with a number on the end here, and I'll have zeros in the places of all the x's and -2 on the end, so -2 is not equal to 0. Minus 2 is not equal to 0, so that one doesn't work. What if we try -1 next? -1 cubed minus -1 squared minus -1 minus 2. What do we get? -1 cubed is minus 1. Minus 1 squared is plus 1, but we have this minus outside, so minus 1. Minus 1 is plus 1. Minus 2, so this is not equal to 0, so that's not a factor. I don't think. Minus 4, that's minus 3 or something, right? So let's try 1. 1 cubed minus 1 squared minus 1 minus 2. What the hell? Should probably use brackets here. 1 minus 1 minus 1 minus 2. That's also not equal to 0. Check here. Okay, let's try 2. Hope I haven't picked a bad example where we don't have a nice rational factor. 2 cubed minus 2 squared minus 2 minus 2. What do we get here? We have 8 minus 4 minus 2 minus 2. That looks good, right? Because this here equals negative 8. Here's positive 8. That one equals 0. Good. So we found a root. This means x equals 2 is a root. So this is one of our solutions. This is one of the answers that we have here. X minus 2 is a root. But going further to find the rest of the roots, it means that x minus 2 is a factor of q of x, I should say. So what we're going to do, we're going to divide it in and see what we get. This was x cubed minus x squared minus x minus 2, I think. It's x minus 2, yep. So we're dividing in now. And running through this division, we have x squared. Multiplying by the x minus 2, it's x cubed minus 2x squared. Minus plus. Cancels. 2x squared minus x squared is x squared. X into x squared is x. X times x minus 2 is x squared minus 2x. Changing my signs again. 2x minus x is x. X into x is 1. X minus 2. As we expected, we're getting 0 as a remainder, which is what we want. And this tells me that q of x, which was x cubed minus x squared minus x minus 2, that's equal to the thing that I divided in, which was x minus 2, that was the factor, multiplied by the quotient up on top, x squared plus x plus 1. Okay, so going back, so bringing it all together. Together, okay. We started off trying to solve x to the 4 minus x cubed minus x squared minus 2x equal to 0. That was the original question, right? So first thing we did was we factored out the factored out the x. After that, we tried some numbers and we found that 2 was a root, so the x minus 2 was a factor. And the other factor then was x squared plus x plus 1. So our answers then were this one here, we get x equals 0. Why were you not right on my screen? Here you have x minus 2 equals 0, which means that x equals 2. And for this one, what we have to solve is x squared plus x plus 1 equal to 0. Okay, I look at that one there, and I think I can't factor that. I can't get numbers that multiply to make 1 and add to make 1. But what I am noticing is that I could go ahead and do the minus b formula. So what you might do is try to solve using the quadratic formula. So in doing this one here, remember, so in here it's going to be a equals 1, b equals, sorry, not 2, b equals 1, and also c equals 1. Minus 1 plus or minus the square root of b squared, which is 1, minus 4 times 1 times 1 is 4, all over 2 times 1. So it's maybe now that you notice that I have a problem, because in here there's a negative under the square root. Negative under the root, so no solutions to this part here. So there's no solutions to this x squared plus x plus 1. It is never equal to 0. Therefore your only solutions to the equation were the ones we already found. First of all, it was x equals 0 by factoring, and then it was x equals 2 by trial and error. When we tried to find more solutions, we realized that the negative discriminant means no real solutions to the last part, so only just 0 and 2 will work. Okay. Any questions here? No questions? Okay, well, so we'll move on to the next topic then, rational equations soon. But this seems like a good place to take a break, because we've just kind of finished a topic here. So what I'm going to say is break until 11:25 a.m. 10 minutes. So go get a quick snack or drink of water, whatever it is you want to do. And I'll restart again at 11:25, and when I do, we'll move on to rational equations. We did rational expressions before. This is where your rational expression is equal to 0 and you find solutions. Okay, so quick break, and I'll see you again at 11:25. Make sure you're back on time. A lot to get through again today. Okay, I'm going to move on to rational equations. Unless anyone has a question after kind of maybe in the break you digested a little bit of this and realize you want to ask a question just before I move on. Are you sure it says that in the syllabus? It's only the midterm. You only have quizzes on the weeks that you don't have midterms. Let me just double check that. No, it doesn't say that in the syllabus. Let me. So this is where you can find the information in the syllabus for most of the questions that I get asked. I don't know if you can see it. It's not presenting for me, so I'm going to stop and start again. Come on. Here we go. So on this page over here, if you scroll down from the top, down past the outline, past the evaluation into this here, the assignments and tests. Quiz 3 was already done on Friday, so midterm is July 30th, but you don't have anything for July 30th as well. You only have quizzes on the weeks that you don't have midterm or final. So you can think of it as every Friday you have something. If it's a midterm or a final, it's not a quiz. If it's not a midterm or a final, you have a quiz. Second, let me just see what I. Yeah, so for the midterm and final, I was planning on having a Google Meet that you will join, have camera on, microphone off for the entirety of your test. That's in the course syllabus, and it's what to expect. But other than that, it would be just like an assignment, but a 1 hour time limit. I will make the assignment or the midterm come available on Canvas at like 4:59 p.m. or something, so that when you refresh at 4:59 you'll see it. I'll post an announcement for sure, and that'll come as an email. Midterm. Yeah, so Maximus, in the course outline, I have it stated that students must be on a Google Meet call with camera turned on and microphone muted for the entirety of the midterm and final exam. So that's what to expect for the midterm. Yeah, I'll post an announcement as it gets a little bit closer that has all the details that you need. So probably on the Wednesday or Thursday, tomorrow or Thursday, I'll post an announcement that will also send to your emails that will say, here's the Meet link for the midterm. This is what's going to happen with the assignment and so on. Yeah, you do. So the deadline that I'm really looking at is 6:15 p.m. So in theory, you stop at 6 and you hand in at 6:15. And there's a policy in here about losing marks for every couple of minutes that you go beyond 6:15 p.m. You can read about that in the course syllabus as well. Pretty sure. Yeah, so it says in here, you must take the test alone after the test is completed. Students have 15 minutes to submit answers to Gradescope. Students will lose 2% for every minute they're late. So yeah, this is a timed exam. We need 2 accounts, one for laptop and other from a separate device. Why would you need two accounts, Daniel? I don't follow. You can use your laptop with your camera and have the midterm open on your screen. You're writing on pen and paper, and when it's done, you submit it. What do you mean by two accounts? Yeah, a little over 6. So if you end up going to 601 or 602, that's fine, but it has to be submitted at 6:15. So I know how long it takes to submit things to Gradescope. It's not very long. If somebody has gone longer than 15 minutes, I'm assuming that they've gone right up to 6:10 or 6:12 or something, trying to write answers, and you'll be subject to the late policy if you're over 6:15. This is a timed exam to mimic it, just like what you're going to see in university. Assignments are not timed. You have a whole week for those, and quizzes, you have a handful of questions for half an hour for very few questions. So this one is timed. But yeah, 601, 602. Midterm, again, this is all in the course syllabus. You should all definitely be reading the course syllabus more carefully. Midterm is 30% of your final grade. Quiz is 10%, assignments 20%, midterm 30, final 40. Adding up to 100. One whole PDF. You can do it as questions as well. So on Gradescope, you're able to take pictures of a question and submit it. So I'll have it set up so that you can submit question 1, question 2, question 3, and you have to label which question so that when I click to mark all the question 1s, I get them one after the other. If you haven't labeled it correctly, I won't see your answer. It doesn't have to be a PDF. It can be with your phone as well. I'd say the easiest way to do it is to have Gradescope logged in on your phone's browser, and when you click into it, I believe you can click question 1 and then take a photo. Question 2, take a photo of your question 2. I think it can work like that as well, right? So I think it's an easier way than scanning and creating PDFs and everything. But if you're quick with making PDFs, if you have some kind of a phone scanner app that makes a PDF and you can email it to your computer or whatever it might be, and then upload that way, that's fine too. You should have to practice by now of submitting to Gradescope, so it should be something that you're comfortable with now. Okay. Any other questions? And most of the questions I got today about assignment and quizzes the answer was all in the course syllabus. Make sure that you read that and you treat it as something that you check whenever you're not sure about something. Do we have an example photo for the condition for the test? I don't understand your question. What do you mean an example photo? Okay, well, maybe send me an email because I don't really follow what you mean by that question, and I have to get on with the rest of the content now. So I'm going to move on here. Okay, moving on to rational equations. One second, just have to check something real quick. Sorry about that. Busy day today. Okay, yeah. So back to rational equations. There are some steps that you can take to solve rational equations, but I mean, you might have your own way, and you might not follow these steps exactly. Like for example, in the textbook, I think I followed them exactly as they say in the first example, and then I do something slightly different on the second example. So follow these steps if you're not sure how to do it, and you're looking for just some steps in English telling you what to do. But if this is something you're comfortable with, which I think you'll be more familiar with these kind of problems than you were with the long division and the solving equations that we just did. But if you have your own way that you know works as well, I'm sure I'll understand it, so you can do it that way too. So if you have a rational equation, again, just keep an eye on this example just below you here. The instructions are gather all non-zero terms to the left side of the equation, factor all denominators. That's going to be important because you want to find the lowest common multiple of all the denominators. And when you do that, you're going to combine it all into one term, add up all the terms and everything, and then multiply across by the denominator to solve the remaining polynomial. So with the example here, you know, I really hate reading off pre-done examples. I'd much rather do it live. So you can find it in the notes if you want to, if you don't like my writing or something, or if your internet bugs out for a second. But here is an example of it. So 2 over x minus 3 plus 1 over x plus 5 equals 22 over x squared plus 2x minus 15. Okay, so the first instruction was to gather all terms to the left side of the equation. Now, it's not really a strictly necessary step. You can do that kind of stuff later when you're going to solve, but it's kind of nice to do it in the beginning too. When that comes across the equal sign, it becomes a negative. And the next step was to factor all denominators. So what do you get when you factor x squared minus 2x minus 15? You want numbers that multiply to make negative 15 and add to make positive 2. That sounds like plus 5 and minus 3 to me. So what we need to do next is find the common denominator. So this, right now, this looks just like what you would do for a rational expression. Like if you didn't have that first line up there and you didn't have this equal sign, and I'm saying simplify this, this is what you would be doing. You would be factoring the denominator. You'd be looking for the lowest common denominator that you're going to make sure each term has it, and then you're going to add them all together. But all that's going to happen is we're going to take all those same steps, except at the end we're going to solve for some x's. So for the first one, we have an x minus 3 here. Now, the lowest common multiple of all these denominators is going to be x plus 5 times x minus 3. So this first term is missing the x plus 5. The second term here is 1 over x plus 5. That one is missing the x minus 3. So we're going to multiply above and below by that. And the last term has both of those factors. So we don't need to do anything with that last term. Multiplying out some brackets, I see 2x plus 10 over x plus 5 times x minus 3. X minus 3 over x plus 5 times x minus 3. And this one here is just 22. So this should look okay so far. It's the same kind of stuff you've practiced already, except there's an equal 0 attached to the end right now. They all have the same denominator, so we can add them all up. And then we can add up all these terms on top here. Adding up, 2x plus x is 3x. 10 minus 25 is minus 15. And next, what you can do is you can multiply across by the denominator too, so that you just have a polynomial to solve. So multiplying across, he wants you right. There you go. Multiplying across by, whoops, I think I have the wrong, x minus 5 instead of x minus 3. Thank you, yeah. That's a mistake I had there. X plus 5 times x minus 3. We get, okay, let's do it. X minus 5 times x minus 3 multiplied by 3x minus 15 over x plus 5 times x minus 3 is equal to 0 multiplied by x plus 5 times x minus 3. Okay, so by multiplying across, these denominators cancel. I have 0 being multiplied by something on the right side, so that's just going to be 0. So what I have now is 3x minus 15 equal to 0, meaning that 3x is equal to 15. And dividing across by 3, 15 divided by 3 is 5. So 5 is the solution to this rational equation. Any questions here? Can I get 1, 2, 3, 4, 5 in the chat for the comfort level with these kind of rational equations? Anyone else? Okay, very good, very good. Okay, I'll do one more then, and we'll, just so that you've seen another thing. And I won't follow the steps to the letter this time. I'll do it slightly different. If maybe you might have done it a little bit different before as well, so that you can just get a refresher on that too. So let's say we have to solve x over x plus 1 minus x equals 3 plus 3 over x squared minus 1. Okay, so just curious, if one of you guys were solving this and you don't normally, sorry, I'm a bit tired. I didn't really get much sleep last night with the heat. What was I trying to ask you? Does anybody solve this without bringing everything to the left side of the equation? Just any yeses in the chat if you do. Like, my habit would have always been to clear the denominators and then worry about sorting stuff out later. That's something you can do too. So another way to start it is to just factor all the denominators and then multiply across by any factor that you see. So x over x plus 1 minus x equals 3 plus 3 over this here factor is going to be x plus 1 times x minus 1. So what I could just do right now is multiply across by x plus 1 multiplied by x minus 1 to clear the denominators. It's going to lead to the same answer in the end, but maybe just a few less steps. So when I do so, just write the thing that I'm multiplying by in here in blue. It's 3 plus plus 1 times x minus 1 multiplied by 3 over x plus 1 times x minus 1. Okay? I do this because I want to make a bunch of cancellations. I see an x plus 1 that cancels here. I see this entire thing cancelling here. And now I have x times x minus 1 here, minus x times x plus 1 times x minus 1, 3 times x plus 1 times x minus 1, plus 3. Okay, so what I need to do now is multiply everything out and gather everything to the left side of the equation and see if I can refactor. So let's see what I get here. I get x squared minus x. I think the easiest thing to do here is probably transform that x plus 1 times x minus 1 back into that. Then multiply out some more brackets. And now I'm noticing that -3 and +3 cancel. Anybody have any questions? Does this feel like I'm going a little fast or anything, or is it okay? People feel okay, pretty much. Okay, so I'm going to bring everything to the left side now and kind of write it in the order that we're most used to, starting from the biggest power and working my way down. I see a minus x cubed here. I see an x squared and a 3x squared here, which I'm going to add. Bringing the 3x squared across, it becomes negative, and I have minus 2x squared. I see an x term and an x term. Actually, those cancel. I don't know how I missed that. Let me take away this highlighter here. Minus x and plus x cancel. Wait, that's all I have, isn't it? I have minus x cubed plus x squared. Or sorry, minus 2x squared. So that's equal to 0. Okay, so one thing I can do is I can multiply across by -1. Get rid of some of those minus signs. Oops, I missed my power too, didn't I? Yes, I did. Yep. And we're almost there. How do we solve this one? X cubed, maybe you're thinking grouping, maybe you're thinking quadratic formula. What are you thinking here? What do I do next? Factor out the x squared, exactly. So x squared comes out, leaving me with x plus 2. Common factor, that's it, Lewis. So to solve it then, x squared can be 0, or x plus 2 can be 0. Now if x squared is 0, that means x has to be 0. And if x plus 2 is 0, then x is -2. So those are my solutions, 0 and -2. Okay. Any questions here? I lost at the very end. Whereabouts? So you were okay with the common term factoring. You took out x squared, and you were left with x squared times x plus 2. So just like with any other, let's say you did a quadratic equation and you ended up with that, right? You would say, well, the solutions are when that equals 0, or when that equals 0. So that same idea here. This is one factor, and that there is another factor. So the solutions are when either one of those factors are 0. So either, yeah. Okay, I'll stop if you're happy. It's hard to teach online this way. I can't look at anybody's faces to see a quick nod or a confused look. I need you to voice it in the chat, everybody, if you're not sure about something. Okay. So that's rational equations, a quick reminder there. I think most of you are probably going to be fine with that. What I really should have said actually at the very beginning of this is, and it's in the book though, but a rational equation is, you know what, I'm going to say it just here. A rational function is a function of the form, just so you have a general definition for px over qx, where p and q are polynomials. So just quick note there. I already said what a polynomial was. Well, the rational functions take from that. It's a polynomial divided by another polynomial. You might be inclined to think in them, you might kind of colloquially think of them as fractions with x's involved, and that's fine too. Okay, so moving on then to the last type of function we were going to look at today was absolute value functions and absolute value equations. So I'm going to start with a reminder of what an absolute value function is, and then we're going to solve some equations that have absolute values involved. Okay, so this here you can think of as the definition of the absolute value of x, like this, right? So it's the absolute value of x equals x if x is greater than or equal to 0, and negative x if x is less than 0. Okay, so that there you can think of as the definition of the absolute value of x. But it isn't, you don't really think of this when you think of absolute values in practice. Like, can somebody write in a few words in the chat or even unmute and just say, what comes to mind when I say the absolute value of something? Like, what's the absolute value do? You know what this is, right? Always positive. Yeah, that's one thing about it. If you're looking at the absolute value of some expression, you're going to say, oh, that makes sure that it's always going to be positive or 0. I guess 0 isn't really positive or negative. So let's say always non-negative, always positive or 0. Yeah. And what does it do? With that kind of thing in mind, always positive, it makes negative things positive. So what does the absolute value do to a positive number? Nothing. It doesn't do anything to a positive number. The absolute value of 5 is 5. The absolute value of 50.2 is 50.2. But the absolute value of negative 1 is 1. The absolute value of negative 9 is positive 9. So the way I would think of it in practice is, in practice, I think of the absolute value as something as, I should be a little more specific than something, as a function that makes negative numbers positive and does not change positive numbers. So absolute value of -5 is equal to 5. Absolute value of 0, for example, is equal to 0. Absolute value of 7, that's just equal to 7. Okay. Now, going back to this definition that I wrote up here, that looks a little bit complicated for such a basic thing, right? But this is just the kind of formal way that you can understand it. It's the mathematical kind of the more pure way of like saying makes negative positive. You use symbols and so on. So how is it working? Well, so using the formula above, so this was that the absolute value of x is equal to x or negative x, depending on the case. So what would I do if it was minus 5, right? Which category does minus 5 fall into? This one here. X is less than 0 for minus 5. So when I'm looking at this, I'm thinking of selecting the second option, not the first option, because x is less than 0. So the absolute value of x is equal to negative x. Absolute value of minus 5 is equal to minus 5, which is 5. That's what that definition is doing. It's saying that if you plug in something to it that's negative, you do this to it. You multiply it by a negative to make it positive again. If you plug in something that's positive into it, you do absolutely nothing. You just drop the absolute value bars. Okay? So you might see this definition from time to time in textbooks or in notes and stuff. It might look a little more complicated, but it is doing exactly what you expect it to do. For positive things, for x equal to 0, it just leaves it alone. You just drop the absolute value bars. And for negative things, well, you multiply it by a negative to make it positive. Just like what we did here. We had to do absolute value of minus 5, so we multiplied it by the minus to make it positive. That's kind of the formal mathematical definition for it. Now, in practice, it's not really something that you use, but it's good to understand how things are written formally in maths at times. You're going to see things that look complicated, but when you actually dig into it, it's not that complicated. It is doing what you expect it to do. So let's do a few examples here and try to solve some absolute value equations. Let's say I want to solve the absolute value of x equal to 7. Well, what are my solutions here? If the x value in here equals plus 7 or minus 7, the equation is true. So x equals 7 or x equals minus 7, those both work because the absolute value of 7 equals 7 and the absolute value of minus 7 equals 7. Those are both okay. You follow? So you're often going to find two solutions to absolute value equations because the positive and the negative of it both work in the equation. Any questions so far? Everyone satisfied? Okay, let's look at a slightly different one. What if we have absolute value of x minus 3 equal to 4? Okay. Well, again, I'm not really going back to the formal definition because it's a bit more positive. This equation works if the expression inside the absolute value bars equals 4 or minus 4. Okay. So your options are x minus 3 equals 4, x minus 3 equals -4. Those are the two solutions that you can have. So x equals 7 or x equals -1. And as always, you can always, whenever we solve equations like this, we can always check our answer. So let's say we check the absolute value of 7 minus 4. That is the absolute value of 3. Sorry, I'm being stupid. The absolute value of 7 minus 3, that's what the original question was. The absolute is equal to 7 minus 3 is 4, and the absolute value of 4 is 4. That one works. The absolute value of -1 minus 3, that's the absolute value of -4, which is 4. That also works. So those are both solutions to the equation. Okay. Any questions here? Give me your 1 to 5s. I have no idea how you're doing here. 1 to 5, 1 is bad, 5 is good. Okay. Yeah, let's throw you a curveball. All of the everybody seems satisfied 4s and 5s. So what about this one here? What's the answer to this one? Somebody write the answers in the chat, or write something in the chat if you're not sure. Just look carefully at this one now. Any thoughts? -2 and 4. Anybody agree or disagree? Why, Lewis? Maybe you want to unmute?
I mean, I just know that anything inside of the absolute value will become positive at the end. So it's really good answers, but I don't really know how to get to the -3.
You can't. You're exactly right. You've spotted. So this was a bit of a trick question. I apologize for that one. But you have to just be a little bit careful at times. Lewis is exactly right there. Anything that's on the left side is going to be positive. So we're trying to equate a positive thing. Positive equals negative. So this is not possible, and there's no solutions. Another way to think of this, actually, because you saw these graphs before. Do you know what the graph of the absolute value looks like, if you can remember? It looks like that V shape, right? So if you remember your transformations, what does x minus 1 look like? That's going to be 1 to the right. So if you're trying to solve where this equals -3, let's say -3 is down here. There's no place, like if we draw our line across here, it doesn't intersect. There's no place where the absolute value of x minus 1 comes down far enough for it to be equal to -3. So no solutions here. Okay. Yeah, sorry about that one. That was a tricky one. When everybody feels really confident about something, I like to just make sure that you're not kind of taking it too lightly at the same time. Like, it's good that you're able to do the calculation, and that's good. But sometimes, and I'm guilty of this too, you can kind of switch off and forget what's going on a little bit because you just do the calculation. You're like, yeah, easy peasy. And it's good to remember just to be a little bit careful sometimes too. We'll see this again when we get to log functions. There's certain things that can happen in the log laws where you get solutions that aren't really solutions, and you might be comfortable with the log laws, but you just have to double check some things. So just something to watch out for. I don't plan on tricking you in a test or anything with something like that and having somebody, get the wrong answers or something, but just something to be aware of. You might just see it 9 to 9. Okay, I'm gonna have to mute this again. I really, really don't want to miss this call though. Yeah, we'll do one more, a little bit more complicated. So what number was that? That was number 3. Let's do one more, slightly more complicated one. It doesn't get much more complicated though, so you're probably going to find you're comfortable with this. If you've already written 4 or 5 and you got tripped up with that last one, that's okay. You're not going to be too bad here. Okay, so let's say we have to solve the absolute value of x squared plus x minus 4 equals x. It looks more complicated than before. We're not just saying x minus 3 equals 2, so bring the 3 across. There's a little bit more complicated to do. But this equation is solved. Is solved when this equals plus x or minus x. If that thing inside those bars on the left side equals plus x, then the absolute value of x equals x. If it's equal to negative x, the absolute value of bars also fix it and make it equal to x. So that's what we have to do. So 2 cases, just like all the other times. We have x squared plus x minus 4x equals x. And we have x squared plus x minus 4 equals negative x. Those will both work. Because if we look at this here, absolute value of x equals x, and the absolute value of negative x is also going to be equal to x. So those are the two cases that we're doing here. Okay. So, but now immediately after doing it, it looks a little more complicated, but we're back to basics again. The x and the x on this side cancel. X squared minus 4 equals 0. This is a difference of squares. So you might be seeing now why I was really insisting that your factoring should be like the alphabet, A, B, C, D, E, F, G, easy peasy. I don't have to spend time worrying. There's other things that are going to come up. There's going to be absolute values involved, and polynomials and rational functions and equations, and exponents and logs are coming up soon as well. And there's whatever it might be, finding x and y intercepts to graph things. You don't want to get tripped up on the week 1 stuff and like spend a whole bunch of energy going, this is how you factor it, when you need that energy for something different. So you want to just have that practiced enough that it's just done. Any factoring stuff is easy for you. Okay, so next up we can bring the x across. This time it doesn't cancel because it's negative on the other side. Why will this not write? So in here I'm looking for something that multiplies to make negative 4 and adds to make positive 2. Doesn't look like it's going to happen. So we shall use the quadratic formula. Again, also something that you don't want to be struggling and stressing about, do you remember it or not. You want to just have it learned so that, boom, on the page, like the alphabet. So that you can focus on the things that you want to focus on, like solving a big polynomial thing, or keeping all your roots together and have a neat work where you can kind of list your answers at the end and long division. And you want all this stuff to be so kind of fluid that you practice it enough that you just write it down. Especially when it gets to calculus next term as well. You don't want to be slow on the high school stuff, and really it is all just practice. Minus 2 plus or minus the square root of 4 plus 16 over 2. So I'm just skipping some of the calculation here. Minus 2 plus or minus root 20. You should remember how to simplify square roots from the radical thing that we did, the review. 20 is equal to 4 times 5. That's what I want to use. So root 20 is root 4 by 5, which is going to be 2 root 5. Sorry, I'm just going to have to take this call. My apologies, the air conditioner guy just called, so he's going to be here in 10 minutes, so you're going to get another little break here in about 10 minutes where I have to go down and let him in and maybe just, show him to the unit in the basement and stuff so he can check things. And so another quick break coming up soon. Lewis, are you sure it's minus 2? I think so. Okay. So minus 2 plus or minus this root 20 is going to be 2 root 5. So, okay, I should really, you can factor out the 2 here and cancel right now, which, I think that might confuse you a little bit. So what I'm going to do is write them separately. My answers here are minus 2 plus root 5, sorry, plus 2 root 5 over 2, and x equals minus 2 root 5 over 2. So to simplify this a little bit, I can factor out that 2 on top. I think I made a mistake, have I? Yeah, I factored out a minus 2. So that would be 1 minus root 5 here. My 2's cancel. Sorry, you know what? Let me rewind a little bit. I'm a little bit distracted by that call, so I'm not doing things most efficiently right now. Minus 1. I'm just going to take out the 2's. 2's cancel. And what we have then is our answers minus 1 plus root 5 and minus 1 minus root 5. So these are our other 2 solutions. So going back up, yeah, this one got a bit longer and it got interrupted. So let me just summarize here. We had this equation up here to solve. And we said that it works when that thing inside the absolute value bars is equal to the plus of the right-hand side or the minus of the right-hand side. So we did both of those cases. We did the plus right-hand side here and the minus right-hand side here. First one was easy enough. We cancelled the x's factored by difference of squares and solved to get minus 2 and 2. The second one, it wouldn't factor nicely for us, so we used the minus b formula. And all in all, our solutions then are these ones that we got from the minus b formula, but also not forgetting these ones up here. These are also solutions to this question. I just wrote that right through my equation there, so I'm going to leave it there. Okay, how are we feeling about absolute value equations now? Still feel good? Just a little more complicated, the same concept, right? You take the thing inside the bars, make it equal to the plus of the right-hand side and the negative of the right-hand side and solve 2 kind of questions side by side. Okay, any questions here? So we've ran over solving polynomials, solving rationals, solving absolute values. equations for all of them. What we're moving on to now for the last little bit here is going to be solving inequalities. Okay. So I'm going to run back to the textbook here and, oh, sorry, just saw your question notice. Yes, you have 4 answers at the end. 4 answers work. And you can check all those. You can sub them in and see if they work if you want. They should all work. Okay. The square root ones are going to be kind of nasty to check because there's going to be awkward calculation, but if you check it, it should work. So that was the absolute value equations. And there's some exercises here on this chapter that you should definitely do all of them. Solve using factoring, practice your long division, solve some polynomials, solve some rational equations, and solve some absolute value equations as well. Okay. So solving inequalities, again, we're going back to interval notation to give answers here, because if you remember, if you're solving an inequality, it's going to be a whole range of numbers that you get. For example, if I'm asking you what is the solution to x less than 4, well, it's 3.9, 3.8, 3.7, 3214, minus 50. They're all correct answers because all those numbers are less than 4. So when you're given the answer to an inequality, you're giving an interval or maybe multiple intervals. So we're back using that interval notation, which we touched on when we did domain. We're back using it now. So if you remember the soft brackets, the hard brackets, and for inequalities, what to remember is that if you're using less than or equal to or greater than or equal to, most of the time that means that the kind of key numbers or the endpoints that you solve are part of the solution. It's only different if we do rational inequalities. So you're going to use the hard bracket on those. And whenever there's less than or greater than without the equal underneath, it's soft brackets everywhere. So just something to watch out for when we're doing this. Something else on inequalities is that you can treat them just like equations for the most part, apart from a couple of exceptions. If you multiply or divide across an inequality by a negative number, or even something that can possibly be negative, this is why you don't really see multiplying across by x in an inequality, because if that x can be negative or positive, do I flip the inequality symbol or not? Depends on x, doesn't it? So it's not something we do very much. But for example, minus 4 less than 2, if you multiply that across by negative 1, you would have 4 bigger than minus 2. So both of these are correct. If you didn't change it, if you multiplied across by negative 1, you would be saying 4 is less than negative 2, which is not true. So don't forget to change the direction. Here it went from less than to greater than for multiplying across by a negative number. Something else that you don't do in inequalities is you don't square both sides. Again, this can be something that leads to trouble. For example, going back to minus 4 being less than 2, if you squared both sides here, you would be saying that 16 is less than 4, which is also incorrect. So just 2 things to avoid doing, or if you multiply, or think about it, if you multiply or divide across by a negative number, change the direction of the inequality, and don't square both sides of an inequality as well. It could lead to mistakes too. If both things are positive, it's probably still correct, but still just avoid it anyway. Okay, I think I heard car outside, so just let's call this a 10-minute break. So one more break you get today. We're going to break until 12:30, okay? And I will be back then. Okay, so the guy is working on my air conditioner outside. If I told everybody to break until 12:30, so if there's anyone still here, I'm not going to start until 12:30 in case people left and are getting a snack or in the washroom or something. So, but if you have any questions about anything, you can ask it right now, and then we'll start again in 5 minutes. I might get interrupted again if he has to get me to pay or something. So, yeah, we're almost at the end of the class anyway, though. Okay, 12:29. just about at the end of your next break. I better wait just in case. Okay, so for linear inequalities, it's going to work like you would think it would with equations. You bring the x's to one side, numbers to the other, and you get your solution then. So for an easy one to begin with, bring the 5 across. 4 minus 5 is -1. X less than -1, you want to describe that with an interval. So you're going to write -infinity to -1. Always the soft bracket at -infinity. And we're choosing the soft bracket at -1 because this is strictly less than, not less than or equal to. There's no equal there, so it can't be equal to -1. So -1 is not part of the solution. Some other things that you see, maybe a linear one a little bit more complicated. You might just have some brackets to multiply out, some minus signs to distribute. Let's just talk through this one a little bit. When I see something like this, I'm thinking I want the x's on one side, numbers on the other. So I see x's that are tied up inside the brackets here, so I have to multiply those out. -4x minus 8 is what I'm going to get here, and 18 minus 2x over here. Let's bring the x's across. -x minus 2x is going to be -3x on this side, and then bring the -3x across, it becomes +3x. Here 3 minus 8 is -5. Bring the -5 across to be +5, and you have, already we had 4 and 18 is 22, so we have the x's on the left, numbers on the right. Adding up, we get -x less than or equal to 27. And don't forget, when you want x, not minus x, so you multiply across by -1, and that changes the direction of the inequality. So x is bigger than or equal to -27, meaning that the solution goes from -27 to infinity. And this time we chose the hard bracket to indicate that -27 is in there. Okay. Any questions about the linear inequalities? Is that clear enough? Yes, and that should be okay for most of you. Simple enough operations, just to remember about changing the inequality sign if you have to, changing the direction, and the interval notation. You want to remember that from when we did domain. Okay, moving on to polynomial inequalities. Let's say we want to solve something that looks like x squared plus 3x less than 4. Sure, Jamal? Just type your question if you have one. Bring the 4 across, bring everything to one side of the inequality symbol, and factor. So bringing the 4 across, you have x squared plus 3x minus 4. Factoring the x squared plus 3x minus 4, you get x plus 4 times x minus 1. And what you want to do with this before you worry about the inequality is solve where it equals 0. Jamal, you can type your question into the chat if you want. You can find out where the thing equals 0 first. So when you do that, in this case, you get -4 and 1 after you do the factoring. And what you're going to do is use those zeros to split it up. So I think what I'm going to do with this one is go back to my screen here and talk through it. So, window. Okay. What we started with in the book was x squared plus 3x less than 4. And we then said, okay, let's bring everything to one side here. First, so before worrying about the inequality. Solve where the left side equals 0. Okay, so I'll just go back to the text for that one. Okay, so the first one up here, the answer that we got to was x less than -1. Actually, you know what? Maybe I'll go to my screen for that instead. Sorry, it takes a bit of time clicking between these screens. So this was the previous question, right? We did x plus 5 less than 4, so x less than -1. So let's say we have a number line here, right? And right here is -1. If you want to describe all the numbers that are less than -1, you want to describe all this area out here. So what is that? Well, that's all the numbers all the way going back this way to -infinity and going up as far as -1, and we use the soft bracket to indicate that -1 itself is not included. You know what, this looks kind of like a 0, so I'm going to just use a check there. For the other one, after we did the calculation, we ended up saying x greater than or equal to -27. So again, think of a number line. Let's say here's -27. Where are the numbers that are greater than -27? Well, it's -26, -25, -24. So all these numbers out this way, all the way to infinity. So we're going to go from -27 to infinity. We want to include -27 because this time it was greater than or equal to, and infinity always has the soft bracket. Okay. So this is just on the side from the previous questions in the book. Okay, so back to this question. We're trying to find out where x squared plus 3x minus 4 equals 0 first of all. Well, we factor. And we get x equals 1 and x equals -4. No problem. So what are we going to do, right? So what you might realize after we did some graphing last time was that equations of this form here, they're U-shaped like that, right? If you think about the graph of it. Now, it might be like this. It might be like this here. But when there's a positive coefficient on the x squared, it's U-shaped, meaning that it comes and dips down and it goes up in both other directions like that, okay? So what we're actually doing here, once we found these places where it's 0, what we've actually found is that it crosses the x-axis here at 1 and also here at -4. So the graph looks something like that. We don't know where exactly that is, but that doesn't really matter to us right now. If I asked you to graph it, then you would have to do that, but it doesn't matter right now. So now this is all well and good, okay? We're able to do this for quadratic equations because we know what they look like. But if you have anything more complicated, cubics, quartics, and so on, it's not easy to graph them. So you're probably looking at this and thinking, okay, well, my original question was for less than 0. So the answer is this interval in here, right? And my answer is going to be from -4 to 1 because that's where the graph dips below the x-axis and it's negative and therefore less than 0, okay? So that is where it, that's the answer for this one. But in general, right, if we find out where the graph crosses the x-axis, we just cross the x-axis, i.e. where the function equals 0. We just have to test numbers around those zeros to find out where the function is negative or positive. Okay, so in doing this one, okay, I'm thinking I have a number line. Let's say I wasn't able to graph it. And I'm thinking about, I have a number line where I know it's 0, and I'm not very good at graphing, or let's say this is a complicated one where I don't know that it's U-shaped. I'm going to pick random numbers in these intervals here. So minus infinity to minus 4, minus 4 to 1, 1 to 0. So what I can do is I can pick random numbers from the above intervals and test in the function x squared plus 3x minus 4. So let's say from minus infinity to minus 4, minus 4 to 1, and 1 to 0. Let's say in this one, I'm going to test the number 5. Sorry, minus 5, right? If I plug minus 5 in here, I have minus 5 squared plus 3 times minus 5 minus 4. This is going to be 25 minus 15 is 10, minus 4 is 6. That's greater than 0. If I test a number inside this interval here, a number between minus 4 and 1, let's choose 0 and see what that does. So 0 squared plus 3 times 0 minus 4, that's minus 4, which is negative. And if I test the number, sorry, from 1 to infinity is what this should be. A number from 1 to infinity, any number in there, I can test 2, 3, 4, 5, 6, 10, I can test a million if I want. Let's say I test 2. 2 squared plus 3 times 2 minus 4. That's 4 and 6 is 10. 10 minus 4 is 6. That's greater than 0. Now, what we wanted to solve was x squared plus 3x minus 4 less than 0. That was the original question. So after I found where it's equal to 0, we tested and found out that it was less than 0 in this interval in here. So the solution is minus 4 to 1. Okay. Because in the other places, from minus infinity to 4 and from 1 to infinity, it's greater than 0, which means it's positive. So that's not part of the solution. Any questions? How are we feeling on this one? 1 to 5. .5, very specific. Pretty good, feeling pretty good. Okay, good, good. It'll take the practice to nail it, but very good. Let me see where I am. Now, going back to something in the book here, you'll notice if you read ahead, there's a table of pluses and minuses that I want to go through. So I'm going to go back and show you how you're going to use that table, because for certain complicated problems, as you can imagine, right, if I sub in minus 5 into, let's say, a rational function that has a cubic on top and a cubic on the bottom or something, that's a lot of calculations to have to do. And especially if there could be 5 or 6 intervals in there that you have to do it with. So that gets a lot to do in your head and to try and come up with an answer, negative or positive. So if you read ahead in the book, this is on page 78, you'll see there's a table in there. So I'm just going to show you how you can format your answer into something that that you can check. Okay, so this is just about using the table. So we solved that x squared plus 3x minus 4 was equal to 0. That was for x equals -4, wasn't it? And x equals 1. Did I do it wrong earlier? Let me just check. Don't tell me I had a mistake. I did have a mistake. Okay, so I used the wrong, you'll notice I used the wrong numbers here. Wait, there's no mistake. There's no mistake, I'm good. So the solutions that we got were x equals -4 and x equals 1, right? So what you're going to do in general is whenever you find zeros like that, you're going to take those, split the intervals around them, and don't forget that this here was x plus 4 times x minus 1. The way you can create a table to help with this, and it's going to seem a bit like overkill for an easier question like this one, but for the harder questions, it becomes nice to be able to kind of map out your work a little bit. You have x plus 4 is one of the factors, x minus 1 is another. And the product of the two factors here, which is what you're trying to figure out where it's negative and where it's positive. That one there, that's going to be the final line is going to be your answer. So again, you're thinking of random numbers inside these intervals. It doesn't matter which ones. And instead of trying to do the calculation as a whole, you can do it for each factor and then worry about the signs of the factors at the end. So if I plug -5 into x in here, -5 plus 4 is -1, which is negative. If I plug it in here, it is -5 minus 1 is -6. That's also negative. The size of the number doesn't matter. I only care about the signs. If I plug in 0 into this one here, 0 plus 4 is positive, and 0 minus 1 is negative. And if I plug 2 in, so that's into this one in here, 2 plus 4 is 6, which is positive, and 2 minus 1 is 1, which is also positive in this one here. Now, what I care about is the product of the x plus 4 and the x minus 1 that forms to make the actual question that I have. So in this interval in here, in this interval minus infinity to -4, what I have is a minus times a minus, which gives me a plus. Okay. In the second interval, what I have is, so that one was a minus, oops, my bad. That one was a minus by a minus, giving me a plus. In the second one, in this one here, what I have is a plus by a minus, giving me a minus. And in the last one, what I have is, so in 1 to infinity, I found out in the first factor it was positive, in the second factor it was positive. So this thing at the end here, this thing here, the product of the two factors is positive by a positive, which is positive. Okay. So what I'm looking for, what I was looking for in the end was x squared plus 3x minus 4 less than 0, right? Because less than 0, what I was looking for, that's the sign I'm looking for, meaning that this here, this is the correct interval. So -4 to 1 is the correct interval. Now I know we already solved this, right? We already solved this a slightly easier way. But this is a way to do it with the table so that if you have a more complicated question, like it's very possible that you could have a problem here that has 5 or 6 rows over here and 5 or 6 intervals up here, and it just gets hard to do all that in your head. So it's nice to be able to put it on a table, do pluses and minus signs, and it's easier to check your work in the end because you can just check that we have the right pluses and minuses and stuff. Okay. Okay, 1 second. So, tell you what, we're going to leave it there. I want you to read ahead and look at the next question in the book, and I will cover it at the start of the next class as a refresher as well. Okay. I have to run now, but the midterm will only cover up as far as rational expressions. Okay, or rational equations. So the midterm covers up to rational equations, not the absolute value stuff and not the inequalities, okay? So you only have to work up as far as rational equations for that. I'll be posting announcements and whatnot as well, but feel free to email me if you have any questions. But I'm going to stop it here, and I'm going to call it there, okay?